Hello, everybody. In this chapter, we're going to do long-term liabilities. We're going to calculate the market value of a bond when the market rate is not equal to the stated rate on the bond. I'm going to be working out of the accounting workbook worksheet on chapter 16. I'm going to make some slight modifications to it, but here we go. So it states that there's a bond. We'll deal with the first one first, this one. It states that there's a bond. It has a face value of $100,000, market rate of 12%, and a stated rate of 10%. The issue date is January 2014, January 1st of 2014, and the maturity date is December 1st of 2034. And interest is going to be paid. We're going to change this. We're going to pay it yearly so it fits the time value of money table that I have. So it says, what's the market rate? So what we need to do is a couple of calculations. First, let's find out how much time that this bond is for. So this bond is for 20 periods, right? So that's in. And the market rate, which is 12%. So we'll go with our rate as 12%. So what we're going to do, we're going to look on the time value annuity, and we're going to look for two things. First, we're going to look for the present value of the bond, and then the second thing we're going to, the present value of the bond, and the second thing we're going to look for is the present value of the bond payments. So when we go back here, we're going to use 100,000. Multiply that by that present value rate that we have. And that would be 0.10367. We'll get $10,367. So that will be for the sum. Now for the annuity is going to be, if you did the PERT, so the 100,000 times 1 period times, now we're going to use the stated rate here, which is 10%. If you multiply that, you'll get $10,000. So with that, if you took that $10,000 as the annuity payment, and now we're going to multiply it by the factor for the present value annuity, which would be equation here, 7.4. Four, 6, 9, 4, 4. We'll get 74,694.40. So when we add that to the principal calculation, we'll get 84. Let's make sure. 84. No, we're going to get 85,000. And $61.40 as the market value. So that would be your answer, $85,061 $2.40 for your market value. So that's how you would calculate a bond if there was a discount. And if it was a premium, so here you see the bonds at a premium is more than the market rate. You would basically do the same thing. You take 100,000 times it by. So we have the same. Now here we have 10 years. So what we're going to do, we're going to find the periods. So the periods are going to equal the years times biannually means 2 payments a year. So you're going to get 20 periods, right? And then also the interest. So the interest is not going to be, for the market rate, it's not going to be 10%. It'll be 10% divided by 2. So we're going to go 5%. So when we look at our present value chart this time, so let's go back to that chart. The principal times 0.37689, and we'll get the answer of $37,689. So that'll be for the principal. Now for the payments. The interest payments are at 12%. However, because they are biannually, each payment is $6,000. Now we're going to multiply that by the factor that we're going to find again on the present value of annuity. We're going to multiply that by 12.46221, and that'll give us an answer of $74,773.26. So when you add this, you get a total of $112,462.26. So that is your answer for the market value at a premium. And there you go. I hope this helps. Have a great day. If you look here on this time value of annuity chart, we're going to be using the 12%, and we're going to do 20 periods. If you look at 12% and 20 periods, it would fall here at 0.10. So therefore, that's going to be our present value factor that we're going to use. We're going to go with the period. We're going to go with 5% in 20 years. So we're going to be here, 0.37689. So when we go back, we'll multiply which if you see here, we're going to go with the 12% at 20 periods, same as with the principal. So we have the number 7.4699.4. So if we go back, so we're looking at 5% at 20 periods, and here we are, 12.46221. So when we go back,